Welcome back to the conference. I hope you enjoyed the meal. Our next speaker is Justus Winter. He is co-founder and senior developer of Sequoia-PGP, which implements the OpenPGP protocol from scratch. You can think of Sequoia-PGP as an alternative to the well-known but a little bit old GnuPG. Justus is also quite involved in the broader ecosystem of OpenPGP. In this talk, he's going to introduce the Sequoia-PGP project and other projects related to it. He is going to explain as well the authentication features of the OpenPGP protocol and how Debian and other organizations can use it to secure and protect the supply chain of their sources and binary packages. Let's welcome Justus with an applause.
All right, thank you for the great introduction. So as an additional thing, I've included a URL in my slides. So if at any point you have trouble reading the slides and want to follow along on your own device, please head there to get the slides right now. So I've got quite a bit of material to cover, so I will be showing the outline every now and then so that we don't get lost. First, I will introduce Sequoia OpenPGP, who we are, what our goals are, what the status is, and highlight some projects within our scope. I will then highlight the new features of the upcoming OpenPGP revision, which we call V5. Later on, I will talk about authentication, which is a key function and an essential part of every crypto system. And I will show how Debian can improve their use of OpenPGP even further. So let's start. What is Sequoia? Sequoia is an OpenPGP implementation. We are 5 years old by now, and it's written in Rust. And our motivation is manifold, but we worked on GnuPG before, and as you may know, it's a bit hard to modify. And the API is a bit tricky to use at times. And the reason for that is it has grown over half a century. And there aren't that many tests, so it's tricky to modify. You've got tight component coupling. And in fact, many things that happen in GnuPG happen as a side effect of parsing PGP data structures. And we have talked with many downstream users of GnuPG, and many of you are unsatisfied with the way you can use GnuPG in your programs. Let me talk a little bit about Rust. Why Rust? It's not only cool, but it's also a memory-safe systems programming language. And looking back, it has been a great, great tool for the job. But there are certainly some challenges. We heard about the difficulties of packaging Rust, because Rust is, like many modern languages, using lots and lots of small libraries, and those create quite a bit of work for downstream packagers. But I think with time, this will improve in Debian. Another challenge is platform support. So Rust currently doesn't support all the architectures that Debian does. And there are kind of two ways that this will improve. In the short term, Rust C, the compiler, will get a GCC-based backend. And in the mid to long term, GCC will get a Rust frontend. So with Rust heading into the Linux kernel, this issue will be resolved, I think, in the midterm. So we have some technical and some social goals. Let's start with the social ones. So we want to create an inclusive environment. We are obviously creating free software, and we want to be a community-centered project. For us, that means we are developing in the open. We are trying to collaborate with the broader OpenPGP ecosystem, because we understand our mission not only to create a PGP implementation, but also to improve the wider ecosystem as a whole. And we want to work closely with application developers to help them integrate PGP support in their applications and understand their needs and problems. So our technical goals is, we learned a lot from GnuPG, and GnuPG is a bit of an odd one in that it is a command line application first, and then there is a library, GPGME, that's using the command line. And we want to avoid that. We want to be a library first and a command line application or multiple ones second, right? And anything that's possible with the command line application should be possible and easy with the library as well. We want to have an easy API, and the easy thing should be the right thing to do and the secure thing to do. And we want to have great documentation. In fact, when we released 1.0, we spent, before we released it, over a person year just improving the documentation. And for almost every public-facing function, we actually have an example that you can use for your own application code. We have an unopinionated low-level API, meaning we provide the mechanisms, but we don't impose a policy on how you use OpenPGP. And then, because that can be a bit verbose, we want to have a high-level API later on, where that should be easier to use, but we bring a bit more policy into the mix. We're striving for loose component coupling, loads and loads of tests. We have a CI, we test on multiple platforms, and we want to integrate tightly with the environment we run in. So if your operating system has key stores or provides access to hardware, we want to make use of that. We want to make use of TPMs, and we want to make use of OpenPGP smart cards. So, who are we? Sequoia-PGP was founded in 2017 by Neil, Kai, and me. And if you've been around long enough in Debian, you may recognize Neil. And the three of us worked on GnuPG for 2.5 years prior to that. And we learned a lot about GnuPG, its internals, the good things and the bad things. Nowadays, we are 6 people, so Kai left to work on core boot and improving the security of the early boots in data centers. And we are joined by Nora, Victor, Heiko, and Lars. If you have been around long enough, again, you may recognize Lars. Our funding comes mostly from the PEP Foundation. We have some individual projects with the NLNet Foundation. We were supported by the Bau Holland Stiftung and got some private donations, but we are actively looking for alternative funding just to make sure we will be around in the future. So, what's our status? Sequoia-PGP was released in 2020. So we had this API, which we kept stable for 1.5 years, and it has supported us well. There are some warts, but we have been adding functionality, and we are mostly happy with the API. We have a command line front end that's currently stateless and exposes functions that are useful for OpenPGP users and certainly power users like the keyring maintainers. There is a scriptable interface coming that is Lars's project. We are developing a certificate store. Certificate is our term for the public parts of the OpenPGP key. We are working on a secret key store that will abstract over all kinds of secrets, like software keys or any kind of hardware-based key. We have some network services. We do HKP, we do Wicked, we do Dane, hopefully soon. And we have some miscellaneous projects in our repositories. For example, we ported RPM to Sequoia. RPM used to have, or still has, an internal PGP implementation, and we were able to replace it with Sequoia quite easily, actually. We have some GnuPG interoperability. For example, we can talk to the GnuPG agent if that is managing your secrets. And we have loads and loads of ideas here. Welcome to browse and have a look. So one of the more interesting projects is OpenPGP CA, which is a CA solution to manage PGP certificates in organizations. And the neat thing is that it allows authentication of OpenPGP certificates with very little user interaction. In fact, you only have to decide to delegate once, and then that's it. And we do that by shifting the authentication part to a CA admin. And the neat thing is we produce cryptographic artifacts that existing programs like GnuPG can use with their Web of Trust implementation. And if you have that in place in some organization, you can bridge to another organization, and we will come back to that in a moment to see how this can help Debian securely connect with downstream and upstream projects. You may have heard or even used Hagrid, which is the software that powers keys.openpgp.org. And it's one of our earliest spin-offs, and these are the people involved with that loosely. You may recognize DKG. And the thing that sets it apart from other key servers is that it requires consent before it publishes user IDs. And this consent can be revoked, and the information will be removed from the server. So it's a GDPR compliant solution, and it's hosted in the EU, and I haven't heard of any problems. And there are problems with the software. For example, it doesn't federate, it doesn't currently offer a nice way to serve third-party certifications, but we are working on both problems. And since it's becoming an important part of the OpenPGP ecosystem, we are forming a board that will govern both the service and the development of the software. And it has a little known feature. It can host WKD for you. You just have to point your DNS at Hagrid. There is documentation how to do that. And then it will serve WKD for your custom domain. We have the OpenPGP Interoperability Test Suite. It has interoperability, capabilities, correctness, and robustness of different PGP implementations. It does so by leveraging the stateless OpenPGP interface, which is maintained and developed by DKG. And it allows us to plug different implementations into the test suite. Currently, there are around 99 tests. And all in all, we currently feed around 1,100 artifacts into every implementation and see how it performs. And over the course of the 2 years or so it existed, it found at least 92 bugs across a lot of implementations, and these are only the ones I reported. And there are benchmarks coming, because benchmarks, if you're slow, people might not use your solution and hence be less secure. Finally, or not finally, but then there is the RNP Octopus. As you may have heard, Thunderbird now has a native PGP support. And they did that by incorporating Enigmail into Thunderbird and then replacing the OpenPGP.js and GnuPG backends with RNP. And because they don't use the abstraction that's present in Enigmail, unfortunately, the only way we saw how to integrate our solution into that is to re-implement the RNP API and semantics and improve upon that. And we do that, for the subset that Thunderbird actually uses. And despite this being very limiting in a way, we've been able to implement very interesting features, like we have a seamless GnuPG integration. We use GnuPG's Web of Trust implementation. We have a parsimony-like daemon that keeps certificates up to date. We can prevent a surreptitious forwarding attack, and you get all of the benefits of using Sequoia. just by replacing RNP with our solution. Finally, we have the Sequoia GnuPG Chameleon in the works. So the motivation is many existing programs directly or indirectly use GnuPG. Right? They may invoke it directly, they may use GPGME, or they may use gmime, which in turn uses GPGME, and then that uses GnuPG. And it's infeasible to port all the applications ourselves in a short time frame. And unfortunately, that results in kind of a lock-in, right? There is no migration path, neither for the users nor for developers. And we are trying to break that kind of lock-in by re-implementing the GnuPG command line interface, which is a bit of a daunting task. But I started with, this is my NLNet project, and I started with GPGV, which is the subset of GnuPG that only deals with detached signature verification. And I have that implemented to the point that nowadays on my Debian desktop, I use my GPGV implementation to authenticate all my Debian package lists. That works great. Okay, let's talk about the revision of OpenPGP. So RFC 4880 was released in 2007 and is, has to be revised. Cryptographic algorithms change, become weak, we need new ones. And there was an attempt to do that, but that was never ratified by the working group. And we were kind of stuck. And then the working group founded a design team. Members of the design team were Stephen Farrell, DKG, who are chairing the working group, Paul Waters, who is nowadays the sole editor of the draft. There's Jeffrey Lau from RNP, Niebe from GnuPG, Daniel Huygens from Proton, who are maintaining OpenPGP JS and GOpenPGP, and then me from Sequoia. So every major OpenPGP implementation had a representative in the design team. We had weekly meetings for over a year now. We sent status reports to the mailing list. Most of the work was done in GitLab, and we are at the point that the revision of the OpenPGP protocol is in working group last call, and there is a session in the upcoming IETF. And if everything goes as planned, there will be a revised version of OpenPGP later this year. So, what's coming? So I think the highlight is authenticated encryption is coming. And we did it a little bit differently from the RFC 4880 BIS attempt, where we derive per message keys from session keys. And there are two main benefits to that. First, you get key space separation between AED modes and ciphers, meaning you prevent cross-grade or downgrade attacks. And because we KDF in assault, in the future, if you get an encrypted message, you will be always able to reply to the message encryptedly, even if you don't have the sender's certificate, which I think is one of the main features. Wherever we use symmetric encryption in PGP, we will use AAD, so no more tampering with encrypted keys. For protecting keys or messages with passphrases, we have Argon 2, which is a modern way to derive secret keys from passwords. We have non-deterministic signatures, which is a belts and suspenders approach to protecting against the range of attacks against signatures. We have padding, so we can pad messages and OpenPGP certificates, making it harder to learn anything about a message or certificate by looking at the size, so we plug a metadata leak. We simplified a lot around certificates, where we store metadata in certificates. And finally, this is kind of a heads up and not a win in my book. We use SHA-256 for fingerprints, so we will have really, really long fingerprints in the future. And the design team stands on that as, if you are exposing fingerprints to the user at any time, you are doing something wrong, do it right. So let's quickly look at algorithms. If you look at public key algorithms, the only mandatory algorithms are EDDSA and ECDH. You may do ECDSA and RSA, but DSA and ElGamal are out. Looking at curves, the only mandatory one is ED25519 and OpenPGP's slightly weird adaptation of X25519. And you should also implement the slightly larger curve, ED448 and X448. And you may implement the NIST curve and the brainpool curves. So if you're working for the government, for example, for the US government, you want FIPS compatible algorithms. So we want to make sure that there is a FIPS-compatible subset of OpenPGP in the future. Likewise, the German government likes the brainpool curves and the Chameleon ciphers. So if you need those, they are there. No surprises on the hash algorithms. So the only mandatory one is SHA-256, and all the SHA-2 and 3 variants, or most of them, are in. Out are MD5, SHA-1, and RIPE-MD. Ciphers, we have only one mandatory one, the short AES one. We have the Camellia suite in, and IDEA, TripleDES, and Cast5 are out, except for if you're looking at old messages. In terms of AAD modes, there is, again, only one mandatory one. It's OCB, which is nice because it's fast and the patents were lifted. And you may do EAX or GCM. GCM, again, the only FIPS-approved AAD mode that fits the OpenPGP framework. So we strive for a lean mandatory subset of algorithms to implement. So if you're going for a greenfield deployment, you can have a really, really small implementation. All right, let's quickly look at authentication. Authentication is the process of mapping handles to cryptographic identities. So cryptographic identities in OpenPGP speak are primary keys, and handles can be anything like, your real name, right, or your email address. I'm mostly interested in mapping email addresses to cryptographic identities, but you may be interested in mapping real names to cryptographic identities. And authentication, that's an essential part of a crypto system. If your crypto system doesn't do authentication, in my mind, it's broken. And the way we do authentication is by using trust models. And there are multiple ones. For example, you can do always trust. If you see a key, use it. And that works well until you have an active attacker who does a man-in-the-middle attack. And then you need to be smarter. And most of the time, that means also involving the user more. So you can do tofu, like SSH, and your users don't have to do anything except in a case of conflict, in which you have to ask the user a really hard question. But tofu gives you asymptotic trust, meaning over the time, the trust in the mapping increases, because an attacker would have to keep up the attack in order to be not noticed. So its cost will go up, and eventually the attack is no longer feasible. You can do delegation, which is really nice from an ergonomics perspective. And you can do a kind of centralized delegation like in TLS, or you can do the federated approach like we try to do with OpenPGP CA. You can resort to comparing fingerprints, which is kind of expensive, because if you have n contacts, you need to compare n fingerprints. And if you're doing that, from an ergonomics perspective, you could be doing symmetric crypto, which is much, much easier to implement and reason about. So for me, you should be doing better than requiring a linear cost in terms of the number of contacts. For me, that means either do tofu or do some kind of delegation. Let's have a look how that would look in Debian. I'm actually doing good in time. So, in my mind, there is a right and the wrong way to do delegation. And TLS kind of got it wrong, because in TLS, you delegate to basically strangers, right? You have no relationship to the CAs. The CAs are in for the money mostly. You have no reason to trust the set of, I don't know, hundreds of CAs that come preloaded in your browser or operating systems. But from an ergonomics perspective, it works great. And it has done great things to secure the internet, of course. But there is a better way to do that. And the better way to do that is not to delegate to a stranger, but to someone you actually trust, because that someone is aligned with you and your values. Maybe because that someone is part of your organization, and maybe it's the IT guy in your organization that provisions your laptop anyway, so they have full control over your computing environment. You need to trust them anyway. Why not delegate to that person? And it's very convenient for the user. And it will, I think it will fit great in existing work workflows, right? You onboard a user, you give them a laptop. At that point, you do the delegation step. You set up everything, and they will be able to authenticate everyone currently and everyone who will be joining your organization in the future. And the person you onboarded has to do nothing. And there is a group of people that are in a perfect position to do that in Debian, and that's the Debian keyring maintainers. And what they currently do is curate a set of keyrings, right? And it would be nice, or they could, in the same workflow, create cryptographic artifacts saying, you know, we strongly believe that this association of identity and cryptographic identity is right. And then they create a cryptographic artifact that every one of us and everyone in Debian can consume using their Web of Trust implementation. And it doesn't have to be the keyring maintainers team, but I think they would be in a great position. So I kind of created a fake CA for Debian using our solution, the OpenPGP CA. Can you see my pointer? So here we create a CA. We import the mapping from email address to certificate for all users. This is the interesting step that I kind of faked out here. And then we export all that data into a keyring. And then we can use our or GnuPG's Web of Trust implementation to reason about that. So for example, I can say, use this keyring, start from my CA that I just created, and look up all these certificates that you can authenticate for this email address, for DKG. And then not only will it return all the matching certificates, it will also, our implementation will also tell you how it came to that conclusion. And here's the simple part, right? So, starting from our CA, there is a direct link to the mapping from DKG, the DKG's email address, to the certificate. And that's great. And once that is done, every member of Debian, or everyone who will trust this CA to authenticate Debian email addresses, will be able to authenticate every current and future member of Debian without doing anything else. And now comes the cool part. We can improve upon that, because we can bridge to other organizations' CAs. So imagine every free software project, every distribution, every downstream and upstream user running a CA for their organization. And then you create trust signatures between the CAs. And they can be one way or both ways, doesn't matter. And the neat thing is, we can actually scope the trust to the target domain. So you don't have to trust the target domain, the target CA, to do everything right. You only trust them to authenticate their users. So I would be happy to bridge to the NSA, because I don't give them power to authenticate arbitrary addresses. I only give them power to authenticate their members. So let's have a look how that looks for bridging from Debian to Sequoia. So I create a new bridge, and I will feed in the CA from the Sequoia team, which is real, by the way. And then I export the bridges, and then I will merge in all the Debian certificates, all the bridges, and my personal certificate. And then, using the same command, or in fact GnuPG, I can ask it, what is the correct certificate for my email address? And again, it will return all the certificates matching my email address. And again, it will tell me how it came to that conclusion. Excuse me. So it's fully authenticated. We are going from my certificate authority that I created for Debian. And we see it bridged to the OpenPGP CA running at Sequoia, which in turn authenticated my certificate for my email address. So once this bridge is created, every member of the Debian community will be able to authenticate every member of the Sequoia-PGP community. And I imagine that kind of bridging being done, again, between different free software communities. And we can do even better. Because I imagine a future where OpenPGP does not only do authentication, but authorization. So it can codify and create a cryptographic artifact stating that DKG, or the cryptographic identity associated with him, to have certain roles, like being a Debian developer, or I'm able or I'm authorized to do source distributions for Sequoia. And once we have that in place, you could have, for example, MonkeySphere to use this information to authenticate access to porter boxes. Or Debian packagers can authenticate source distributions made by Sequoia because they can reason about the fact that I'm authorized to do source distributions for Sequoia. And again, if we bridge to different downstream and upstream users in the free software world, I think this is a very plausible way to protect our software supply chain. And this is, for me, a very, very important thing to solve as a free software community. So, let's recap. And we are very good in time, actually. So, I hope I have convinced you that Sequoia is improving the OpenPGP ecosystem, that OpenPGP is alive and well. We are in a much, much better position than we were just, I don't know, 10 years ago. So we have different implementations of OpenPGP. We have, for example, OpenPGP JS, GOpenPGP. We have PG Painless, which is a layer on top of Bouncy Castle. And we have RNP and loads of other, more experimental or more specialized implementations. And we have the test suite that we use, or all these projects use, to improve their implementations and to improve interoperability and align the reasoning about certificates. There is interesting spec work going on. We have the upcoming revision of OpenPGP. We have SOP, which is a common interface for OpenPGP implementations. Currently, this is only a specification for a command line interface, which is in itself very useful, and the test suite makes heavy use of it. But in the future, I mean, we have a Rust interface, we have a Java interface, we have a Python interface. We will hope to have kind of similar looking interfaces for different languages that people can use and, have these, I don't know, 10 or so useful high-level operations that they can use to incorporate OpenPGP into their application. We have the OpenPGP cert spec, which is a way to store OpenPGP certificates in a way that's very, very similar, actually, to the way the keyring maintainers store certificates nowadays. So it's one file per certificate, and then indices to improve or to have performant lookups into this store. And we want to share that across implementations. And this is done in the TLS world, right? We have etc TLS something, right? And we want to have something similar for OpenPGP, so that different implementations running in different languages or something, they should have access to the same set of certificates. They should use the same trust roots and reason about these certificates in a consistent manner. We have a Web of Trust spec, so we want to formalize how the Web of Trust works and specify what design decisions you can do and how to do a performant implementation of this. There are some specs on the horizon, so we want to have a key maintenance spec, which is guidance on how PGP implementations will maintain the keys, like create new signatures, keep them up to date, freshen the key expiration, stuff like that. Symmetric re-encryption is a part of protecting against post-quantum computers, post-quantum attacks on cryptographic systems. And we are working on a way to forward encrypt messages, which is an important feature for companies. If someone goes on vacation, someone else has to be able to read their email and reply accordingly. We have the test suite. So I hope I have convinced you that lots of interesting things are happening in the PGP space, and that in particular OpenPGP is a great way to make the Web of Trust usable. And the key insight is not to treat everybody as a CA, because that is a lot of work, but let them delegate to a CA they trust. And we have concrete tooling to make that easy. And once we add in bridging, we get a true federated solution for authentication. Finally, please don't roll your own crypto protocol. At the very least, you will lose access to all the tools, all the hardware abstractions, all the development tools, the implementations. All that would be gone. All right, so how do you get in contact? Well, this is our website. Conveniently, we decided to move to OFTC, so we are in #Sequoia, and you're invited to join. And this is my address and my fingerprint, but if I have convinced you to, using a CA to authenticate bindings, you could instead use that CA and configure your GnuPG to use that one, and you can scope it to Sequoia-PGP. So you will only give us, or our CA, the power to authenticate our own members. And that's my presentation, and I'm happy to answer your questions. And I will be around. Please come, talk to me, get in touch.
Thank you, Justus, for this great talk. You have convinced me. Does anybody have any question?
Hi, so I'm a Debian developer, but I barely managed to use GPG. I have a hardware token and it works, and when I have to touch it, like change thing on it, I swear for 2 days and eventually something's happened. If I were to replace GPG on my computer right now in SID by Sequoia, what would happen? Would it work?
That's a good question. So we are not quite there yet. We don't have a front end that we can just give to people. As I said, our main front end SQ does not talk to the hardware yet. If you're writing a program, you can make use of secrets managed by the GnuPG agent. And in fact, if you try my prototype GPG replacement, that currently makes transparent use of the agent. So that kind of works. We are not quite yet. Stay tuned.
Okay, thank you for a nice talk. I wanted to pick up on something you mentioned at the end about post-quantum cryptography.
Yes.
I just wondered if you could comment on your roadmap for that and maybe some of your thoughts. For example, will you be using some of the NIST standards or something else? And is there a timeline maybe for implementing that?
Yeah, that's a great question. So the upcoming revision does not address the threat of quantum computers to classic cryptography. We excluded that because we needed to get this update out of the draft status. But people are working on incorporating post-quantum algorithms in OpenPGP, and they are mainly blocked on, indeed, the NIST competition on post-quantum algorithms. But people are looking into that, and we are ready.
Anybody else?
So, again, great talk. Thank you for 2 things. The first one is, as you say, testing. I've lost count of the number of hours I've spent in trying to track down bugs in this kind of area. If you have a good test suite, massively better. And also, thank you for providing a library. Again, I've spent, as my day job and as a Debian developer, I've spent a long time fighting with GnuPG and trying to get it to do the right thing consistently from one version to the next, that kind of thing. A library will make life so much easier. I'm looking forward to using this.
Yeah, indeed. Importing some software that were previously using GnuPG, mostly by GPGME, which is supposed to be a high-level interface, we often saw that even by using our low-level interface, our solution was actually much more compact. And the reason for that is often with GPGME, it wouldn't quite do what you wanted it to do, right? So you had to write a lot of code to get it to do what you want, and that kind of just goes away. So even using our low-level interface right now is often a win for application developers.
Any other question? Okay, then let's thank Justus with an applause for this great talk.